Just one volume mistake in idiometry and the whole answer is wrong. Why do toppers solve idiometry in 30 seconds? Few techniques we are going to discuss, shortcuts for solving idiometry questions after completion of few topics like percentage yield, purity, percentage purity. Few questions we are going to solve. After that we are going to see idiometry. Even these questions are very important questions based on percentage yield. See now. So first, what is percentage yield? So how we show the formula for percentage yield? Percentage yield is equal to actual yield that is given in the question, actual yield by theoretical yield. See what is theoretical yield here? Theoretical yield is according to reaction. According to reaction stoichiometric coefficient, how much amount we will get? That is related to theoretical yield into 100. So we use this to calculate percentage yield of the reaction. Actual yield by theoretical yield into 100. Actual yield is given in the question. Theoretical yield according to the reaction. According to the reaction, how much we get. Based on that, we calculate theoretical yield. So now, based on given information, how we are going to solve the question? See here. Enter information given. So simple reaction, see here now. To identify what is percentage yield here, simple question. When 2 moles of P reacts with 5 moles of Q to form PQ2, when 2 moles of P reacts with, for example, here I am framing, reacting with Q to form PQ2. So here, balanced reaction, if we see here, even reaction specified in the question, I wrote here separately, P plus 2Q giving PQ2. So after balancing, even without giving reactions, you can frame P plus Q, PQ2, balanced reaction 2Q. So now, percentage yield we need to calculate for this. So how we need to calculate? Here they gave 2 moles of P reacts with 5 moles of Q to form PQ2. So first you find limiting reagent. Find here LR. LR, that is limiting reagent. For P, how we need to calculate? Given moles how many? 2 moles by here stoichiometric coefficient is 1, as well as for Q, how many moles given? For Q here 5 moles given, stoichiometric coefficient 2. So here P value, ratio value 2. Here the ratio value for this, it is 2.5. Among these lowest values, so here it is limiting reagent. So now according to limiting reagent, if 1 mole of P can produce 1 mole of PQ2, it is balanced chemical reaction, as limiting reagent is the given one. So if 1 mole of P giving 1 mole of PQ2, if 2 moles of P reacts, we should get 2 moles of PQ2. We should get 2 moles of PQ2. Focus here. The 2 moles of PQ2 according to reaction we should get. Here it is referred as theoretical value. It is theoretical value according to reaction. But here in question what they gave? Here it is theoretical, but given is equal to 1.5 moles given in the question. 1.5 moles given. So now percentage yield is equal to given 1.5, theoretical how much we should get? 2 moles we should get into 100. So every time percentage yield simple, whatever given information and according to reaction how much we should get. So based on that easily calculate percentage yield. Here answer should be, that is 75%, the percentage yield of the reaction. Simple. Where you have to focus here, theoretical according to reaction, actual is according to given data, because some impurities sometimes will get less than expected, that's why we'll get here 75%. Next question, aluminum reacts with sulfur to form aluminum sulfide. If 5.4 grams of aluminum reacts with 12.8 grams of sulfur, gives 12 grams of aluminum sulfide, the percentage yield of reaction. Again here percentage yield of reaction. So here first we need to find limiting reagent again. So reaction you see here, Al plus 3s giving Al2S3. Al2S3. So if we balance it, 2Al plus 3S is equal to Al2S3. So now first you calculate moles of given substances. Moles of aluminum is equal to 5.4 by 27. So here 0.2 moles. Then moles of sulfur is equal to 12.8 by sulfur atomic mass, that is 32. So here moles of sulfur 0.4. So now first find LR. How we find LR? Same trick whatever we discussed in last class. Find LR. So given moles for aluminum 0.2 moles given, stoichiometric coefficient 2. For sulfur given moles 0.4, stoichiometric coefficient 3. So here you will get 0.1, here you will get 0.133. So here LR is the one which is having lowest value for the above ratio, LR. Once if you know LR, based on that we have to calculate further. How? See now. 2 moles of aluminum can produce 1 mole of Al2S3, aluminum sulfide. But here how many moles of aluminum given? Aluminum given 0.2 moles. 0.2 moles of aluminum here will produce 0.2. 2 moles giving 1 mole. So 0.2 moles will give how many moles of aluminum sulfide? What we do here? 0.2 into 1 by 2. So which is here 0.1 moles. So 0.1 moles we got here. Now the amount of Al2S3 is equal to, we know whenever moles given, to find amount what we have to do, we have to multiply with molar mass of Al2S3, molar mass Al2S3 150, 15 grams. 15 grams here, which one? It is theoretical. According to reaction we should get this much. Theoretical according to reaction. But in given question, given is equal to how much? 12 grams. So percentage yield is equal to given by theoretical how much we should get? 15 into 100. Overall here it is 80%. Percentage yield here answer 80%. Same format. Similar question I took here. Same format. I think everyone clear with this concept. Without any confusion you have to do questions here. Next. One more question, that is percentage yield of the reaction. See here, 245 grams of KClO3 on heating yielded 2 moles of CO2. Find percentage yield of reaction. So here KClO3 giving KCl plus O2. If I balance it, 2 KClO3, 2 KCl and 3 O2, 245 grams of KClO3 given here. Even other information also given here. K is equal to 39, Cl is equal to 35.5. Even this information also given in the question. So now, what we need to find? Find percentage yield of reaction. They mentioned here 64 grams of O2 produced. 64 grams of O2 produced. So first you find KClO3 mass. KClO3 mass, which is calculate once KClO3 mass. Potassium 39 plus Cl 35.5. So if we do it, here you will get molecular weight of KClO3 is equal to 122.5. 122.5, that is molar mass of KClO3. So now you see, first to convert the KClO3 given mass into moles, which is 245 by 122.5. So here you will get 2 moles. 2 moles. So according to reaction, 2 moles of KClO3 can produce 3 moles of O2. 3 moles of O2. 3 moles of O2 here. 245 grams of KClO3 on heating yielded 64. Just a minute here. CO2 I mentioned. Just a minute. There is mistake in this. So here yielded 64 grams O2. 64 grams O2. Then find percentage yield of the reaction. So 2 moles of KClO3. See 3 moles of O2 meaning how much amount? 3 into 32. O2 is 32. So it is 96 grams we should get. According to theoretical information, we should get 96 grams. According to reaction. But given amount how much? 64 grams given. So percentage yield is equal to given by expected according to reaction into 100. Given by expected according to reaction into 100. So if I do here, once calculate, here you will get around 66.66%. The percentage yield of the reaction 66.66 is the answer for the given question. So percentage yield based questions easily you can do without any confusion. Once again observe the question. If any doubts, pause the video, try to do further. Next, percentage purity. And there is one more term, percentage purity. So percentage purity, how we calculate? Percentage purity is equal to actual mass of pure substance by total mass of pure substance by total mass of sample. Total mass of sample into 100. Total mass of sample into 100. Actual mass of pure substance by total mass of sample into 100. So percentage purity, how much amount of pure substance by total mass of sample into 100. Sample meaning some other impurities also present. With one question you will get clarity, see here. So mass of the sample taken is, a chalk exactly requires 17.52 grams HCl for complete reaction with all CaCO3 present in it. If the chalk sample is 72% pure, the mass of sample taken is. So see here. First you frame chalk meaning CaCO3. Here it is reacting with 2HCl. After the reaction it is forming CaCl2 plus H2O plus CO2. So here moles of HCl. So moles of HCl if I take, so moles of HCl is 17.52, that is given by molar mass of HCl 36.5 molar mass. Similarly, moles of CaCO3 is equal to how much you will get? According to reaction, if 2 moles of HCl giving 1 mole of CaCO3 reacts with 2 moles of HCl. 1 mole of CaCO3 react with 2 moles of HCl. Then moles of HCl 17.52 by 36.5. Then moles of CaCO3, how much it reacts? Exactly half of this reacts in the reaction. For example, I am writing like this, 17.52 by 36.5 into half of the amount of HCl we take for moles of CaCO3 react. So then weight of CaCO3 is equal to, so here how many moles we are getting? If we calculate here, overall how many moles we are getting, see here. So overall 0.25 moles. 0.25 moles. So weight of CaCO3 0.25 into, it is molar mass of CaCO3, it is molar mass of CaCO3. Overall here you will get 24 grams. So 24 grams of CaCO3 we got when 24 grams of CaCO3 will get if CaCO3 is 100% pure. If it is 100% pure. But in question what they mentioned, you see, 72% pure. So if weight of CaCO3 required, or you can say weight of CaCO3 required, I am writing here clearly. So weight of CaCO3 required, see here, weight of CaCO3 required if 72% pure, if 72% pure sample is taken. So weight of CaCO3 chalk required if 72% pure sample is taken. In last step, what we need to do here, in last step, whatever value we got, 24 grams into 100 by 72. If it is 60% pure, 100 by 60 we have to do. If it is 60% pure, 100 by 60. Same format use every time. Without any confusion, you will get answer here. 33.33 grams. See answer, 33.33 grams when, if it is 72% pure. Once again, see the question. If it is 100% pure, you will get 24 grams. Reaction require 24 grams. But if it is 72% pure, impurity is present, right? So more amount of CaCO3 we need. So that's why we are converting 100% 24 grams, but 72% how much? So then we multiply 100 by 72. If it is 50% pure, we multiply the answer into 100 by 50. If it is 40% pure, 100 by 40 into answer. So remember to calculate percentage purity, or based on purity, you can calculate amount. Next question. 2000 gram sample of CaCO3 is 80% pure. Find weight in grams of pure CaCO3. 2000 gram sample of CaCO3 is 80% pure. Find weight in grams of pure CaCO3. See here now. What they are asking here, 2000 grams, 80% pure CaCO3 sample present. They are asking how much amount of pure CaCO3 present in it. We have to calculate. How to calculate? From this 2000 sample, 80%, that is 1600 grams. 1600 grams is pure CaCO3 plus remaining 400. Here it is impurity. Remaining 4%, that is impurity. That's what. Easily you can observe it without any doubt. Here it is impurity. That is overall how we need to analyze the given reaction. Next, sequential reactions. Sequential reaction. First of all, sequential reaction meaning. Here one question also given for your reference. We'll do now. Sequential reaction meaning. When one of the products formed in previous reaction, when one of the products formed in previous reaction is consumed in the next reaction. So sequential reactions, when one of the products formed in previous reaction is consumed in the next reaction, then we consider it as sequential reactions. See, product of one reaction utilized in next reaction. See, here SO2, product of first reaction, utilized in second reaction. That's why these two are sequential reactions. How many grams of H2SO4 can be obtained from 1320 grams of PBS as per reaction sequence? As per reaction sequence, we have to follow reaction sequence and we need to find how many grams of H2SO4 can be obtained from 1320 grams PBS as per reaction sequence. Remember, actually I said we are going to discuss idiometry, as many questions we are covering under percentage yield, percentage purity. If we discuss idiometry in this video will become longer, little bit longer, which is not so convenient for you. So idiometry topic will be discussed in next lecture. I thought to discuss here itself, as video may extend more than 45 minutes and near to 1 hour, so which is not convenient to watch. If it is short video, that is more convenient to watch. So idiometry will be discussed in upcoming lectures. Currently we will discuss about these questions. So atomic mass of Pb given, sulfur also given 32. So now how we need to use here these sequential reactions to calculate? So first you calculate moles of PBS. Moles of PBS, which is 1320 grams by, you calculate PBS mass, PBS you will get here 240, which is 5.5 moles. Similarly, moles of SO2. Here moles of SO2 also you will get. Why? Here we know one important statement. Here moles of PBS according to reaction is equal to moles of SO2 according to first reaction. According to first reaction, moles of PBS is equal to moles of SO2. So according to first reaction, directly I am writing this. According to first reaction. So direct I am using here now. Then moles of H2SO4, small n representing moles, is equal to 5.5. 5.5 moles of SO2. See now. So moles of PBS is equal to moles of, first of all, moles of SO2. So I am writing here directly for this. So then moles of SO2 is equal to 5.5 moles. 5.5 moles. At the same time, one more here. We know moles of SO2 in second reaction, you see now. Moles of SO2, 3 moles is equal to moles of H2SO4. It is according to second reaction. You see. Second reaction, because 3 moles of SO2 forming 3 moles of H2SO4. So exactly equal both the moles. So if moles of H2SO4 5.5 moles into its molar mass 98, overall you will get 539 grams. So 539 grams is answer. See how we calculated by using sequence. Now question looks lengthy, but you see calculation how simple it is. Only 2 steps. Here what we used? Here 2 PBS, 2 SO2 moles equal. So we made it equal 5.5. 3 SO2, 3 H2SO4. So moles of SO2 H2SO4 equal second reaction. Direct moles into molar mass. We got here, it is molar mass. So overall, based on this, we got answer 539 grams. Next moving further, parallel reactions. First of all, what are parallel reactions? See here. Parallel reactions are when same two reactants form two or more products by independent reactions. When same two reactants form two or more products by independent reactions. So parallel reactions, when same two reactants form two or more products by independent reactions. Means reactions occurs parallelly. Reactions occurs parallelly. How? By using one question here we will see first. Observe it. Carbon reacts with oxygen forming CO and or CO2 depending on availability of O2. Find moles of each product obtained when 160 grams of oxygen react with 12 grams of carbon. So here what we do? So here what we do in this case, 160 grams of oxygen react with 12 grams of carbon. Okay. So in this case, first I am taking C plus half O2 giving CO. See here I am taking less amount of oxygen. When you will get carbon monoxide, whenever you take less amount of O2. So initially we are using reaction with lesser amount of oxygen. So here at time t is equal to 0, 1 mole of carbon, because 12 grams of carbon they mentioned, 1 mole of carbon. Oxygen how much it is? 160 grams of oxygen. 160 grams of oxygen meaning here 5 moles. So see 160 grams, here 5 moles, because 5 into 32. Here 12 grams, 1 mole. So direct I wrote 1 mole of carbon, 5 moles of O2 initially taken. After some time, after completion of time, you can say after infinite time, after completion of time, which is limiting reagent? Direct I am writing, here it is LR. How to find limiting reagent? Given moles by stoichiometric coefficient. Given moles by stoichiometric coefficient if we do, you will get to know which is LR here. So limiting reagent becomes 0 after completion of reaction. From 5 moles, 0.5 moles utilized according to reaction sequence, and then here 4.5 moles left. Then how much amount of CO formed? Limiting reagent decides. 1 mole of carbon will give 1 mole of CO. So here as 1 mole of carbon utilized, so 1 mole of CO produced in this reaction. 1 mole of CO produced in this reaction. So in this reaction, what are leftover substances? See here. In this reaction, CO plus CO, whatever carbon monoxide formed, CO and half O2, both are left. Both are left over in first reaction. Leftover substances in first reaction. So same I am writing now by using those. CO plus half O2 further reacts to form CO2. At time t is equal to 0, how much left here? Means how much amount of CO found? 1 mole in previous reaction. Leftover in reaction. You write here leftover in first reaction. In first reaction. Now in second reaction, these further reacts. 1 mole initially and then half O2, how much left over here? 4.5. 4.5. And then what is limiting reagent again? Again here, if you use method to find limiting reagent, here direct I am writing limiting reagent is CO. After infinite time, after some becomes 0, from 4.5, 0.5 used. How 0.5 used? You see stoichiometric cross multiplication. 1 mole require half mole. So if 1 mole utilized, so half mole removed from it. 0.5, so 4 moles left. 4 moles left in the reaction. According to limiting reagent, here you will get 1 mole of CO2. 1 mole of CO2 obtained. So at the end, after completion of entire reaction, at the end, here you will get 1 mole CO2 and then no CO. CO became 0. At the end, 1 mole CO2 and no CO, because CO completely utilized. Only 1 mole of CO2. What they are asking here? Find moles of each product obtained when 160 grams of. They are asking about product. That's why we are writing about product here. 1 mole of CO. Oxygen available, but here product they are asking. So 1 mole of CO2 left, and there is no amount of CO because whatever produced in first reaction CO utilized in second reaction. That's why nothing left from CO side. Next, POAC, Principle of Atomic Conservation. See, Principle of Atomic Conservation meaning here, POAC stands for, it deals with conservation. It deals with conservation of atoms, of reactants, and products. Reactants and products involved in a chemical reaction. So here we conserve atoms. Simply here we conserve atoms. For example, how to conserve? So you can apply it. It is generally applied. See, POAC generally applied. We apply only for unbalanced equations. When balancing is tough, then we use it. It is generally applied for unbalanced equations. If balancing is tough, difficult to balance, in such cases we use it. How to write POAC? See here. How to apply POAC? See. Means principle of atomic conservation. I am taking simple reaction here. KClO3, see here, KClO3 giving KCl plus O2. Think that reaction not balanced, leave it. For example, if I am conserving potassium, for potassium I am writing, how many potassium atoms here? 1 potassium atom into number of moles of KClO3. In KClO3 only 1 potassium atom. We are conserving, that's why irrespective of equal or not equal, we are using is equal to symbol on both sides. Left hand side, if you are conserving potassium, 1 potassium atom into number of moles of KClO3. Here how many potassium atoms? 1 potassium atom into number of moles of KCl. In O2 no potassium, you can leave it. If you are conserving oxygen, for oxygen, how we write? For oxygen, for conservation of oxygen atoms, 3 oxygen atoms in it, number of moles of KClO3, in KClO3 3 oxygen atoms. So 2 oxygen atoms into number of moles of O2. So here conservation of oxygen, conservation of potassium. We can conserve even chlorine. But in exam, how we know which atom we need to conserve? They will mention, they will give one clue. Which atom we need to apply? Principle of atomic conservation. So see here now. Potassium, oxygen we conserved, even chlorine we can do. Like how to write POAC. So if they provide number of moles of KCl, you can calculate number of moles of KClO3. By using any one equation, any one atom you can conserve for getting answer. See the question now to get answer for this. It's not so tough. Question looks much more complicated. See here. 27.6 of K2CO3 was treated by a series of reagents so as to convert all its carbon atoms. Here you pay attention. All its carbon atoms into given compound. Means they gave clue that we need to conserve carbon atom because they mention all carbon atoms convert into product. So here conservation of carbon atoms you have to follow. Calculate the weight of the product. Molecular weight of K2CO3 is equal to 138. Molecular weight of K2ZN3 FeCN6 6 times. Twice is 698. So here they mention K2CO3 according to given question. K2CO3 after several steps it is converted into K2 ZN3 FeCN6 twice. So entire carbon atom converted into product. So now to which atom we need to apply POAC. So apply POAC. Apply POAC for, as they mentioned, carbon. So I am taking here carbon because all entire carbon converted into product. How you have to conserve? See, first I am writing here how many carbon atoms in K2CO3? 1. So number of moles of K2CO3. In K2CO3, 1 mole of carbon atoms present. Conserve it, so making equal. Here how many carbon atoms present? Right hand side. Right hand side 6 carbon, CN6 twice. So here, sorry, 12 carbon atoms. 12 into number of moles of the entire compound, that is, which is K2, Zn3, Fe. I am writing here. Space not sufficient. I am writing here, see. Conserving carbon atoms. So carbon atoms here it is 1 into number of moles of K2CO3, which is making equal to 12 carbon atoms in right hand side lengthy compound K2 Zn3 into FeCN6 2 times. So here they gave information about K2CO3. What we need to find? Calculate weight of product. To get weight of product, first we should calculate moles first. So how we need to do? Number of moles of K2CO3 first we need to find. And K2CO3 27.6 grams given. K2CO3 mass is 138 is equal to 12 into number of moles of the compound, whatever given product. So here number of moles of compound product is equal to, so number of moles of, or directly you can do it here, number of moles of compound is equal to 27 by 138 into, not into, that is, if you bring this side, here it becomes by 12. These are number of moles of compound, but what they are asking here, weight of compound. Weight of compound meaning, that is, which compound? This one compound is equal to whatever number of moles we got. We write properly. Whatever number of moles we got, 27.6 by 138 in, it's not into, it is here 12. So now if you multiply this by molecular weight of the product, then you will get molecular weight, how much it is? 698. If you do multiplication, then you will get the weight of compound, that is 11.6 grams, which is weight of product. Weight of product. See how easy it is. See, reaction looks very complex, but single step. In single step, I conserved atoms and then substitution of values. Finally, we got number of moles of product first, then followed by, if you multiply with molar mass, it is molar mass. Then you will get answer 11.6. 11.6. So see here, I thought to discuss idiometry in this video itself, but if we discuss idiometry in this video, it becomes more lengthy. So next video will start with idiometry. Meanwhile, complete all these questions, and you can complete questions from your worksheet or module by observing these exemplar questions. I hope the concept is clear to everyone. Percentage yield, percentage purity, important. Upcoming lecture, that is idiometry, also most important. Most of the students face difficulty in idiometry, but with simple tricks we are going to discuss in detail. Anyway, we'll see in next upcoming lecture. Thank you for your patient listening.